Every single hair on your head is not just growing, it's following a script. A deeply embedded biological program that dictates when to grow, when to rest, and even when to fall out. This isn't a continuous process. It's a cycle, an oscillation between intense activity and deliberate dormancy. Deep within the dermis, the hair follicle acts as a miniature self-contained organ. At its base lies the dermal papilla, a cluster of specialized cells that serves as the command center. Above it, in a region known as the bulge, resides a population of some of the most powerful cells in your body. Adult stem cells, quiescently waiting for a signal to begin. The initiation of growth, the anagen phase, begins with a molecular conversation. The dermal papilla sends out signals, primarily from a family of proteins called Wnt. Think of Wnt as the starter pistol. When it binds to the stem cells in the bulge, it activates a pathway involving a molecule called beta-catenin. This molecule travels into the stem cell's nucleus, flipping genetic switches that command proliferation. The cells begin to divide rapidly, migrating downwards to form the new hair shaft. It's a cascade of precise instructions, all kicked off by a single molecular handshake. But this frenetic activity cannot last forever. Growth is metabolically expensive. To counterbalance the go signal of Wnt, another set of proteins comes into play: bone morphogenic proteins, or BMPs. While Wnt signaling encourages growth, BMP signaling actively suppresses it, promoting a state of rest. The balance between these two opposing forces is what orchestrates the entire cycle. As the anagen phase progresses, BMP signals begin to dominate, initiating the catagen phase, a controlled shutdown. The follicle shrinks, cell division ceases, and the hair shaft is cut off from its blood supply, becoming a club hair. What times this molecular tug-of-war? The timing isn't random. Research suggests the hair follicle cycle is coupled to the body's master clock, the circadian rhythm. Your hair follicles actually have their own peripheral clocks, governed by the same clock genes, like BMAL1 and PER, that regulate your sleep-wake cycle. These genes influence the expression of growth factors, meaning the readiness of your hair to grow can fluctuate with the time of day. This raises a fascinating question. Is your hair growth synchronized, in a very subtle way, to the rising and setting of the sun? This intricate cycle is robust, but it can be disrupted. What we call common baldness, or androgenetic alopecia, isn't really about hair falling out. It's about the cycle breaking down. In genetically susceptible individuals, a hormone called dihydrotestosterone, or DHT, binds to receptors in the follicles. This doesn't kill the follicle. Instead, it fundamentally alters the script. It drastically shortens the anagen growth phase and extends the telogen resting phase. With each cycle, the anagen phase gets shorter and shorter, producing a hair that is finer and smaller. Eventually, the growth phase becomes so brief that the hair barely breaches the surface of the skin. The factory is still there, but its production schedule has been corrupted. Understanding this cyclical nature reframes the entire problem. The challenge isn't simply to stop hair loss, but to regain control of the clock. Could we develop therapies that precisely inhibit BMP signaling at the right moment, or enhance the Wnt pathway to prolong the anagen phase indefinitely? Are we looking at a future where we can manipulate this biological rhythm, instructing follicles to stay in a permanent state of growth? The hair on your head isn't just a collection of fibers. It's the visible output of millions of microscopic clocks, each ticking away, and we are only just beginning to learn how to read their time.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.